When it came to these ones, I don't think that this should have been an issue for you at this point. It's just reminding you, hey, remember how to determine what to use. In this case, it seems at first glance that you cannot do it, but remember, if you only have one side, cosine law can't really help you, right? So you have to find a way to come up with a pair. So these two angles give you that one, and now you have a pair. Go with sine law. All three sides. The only one that can tackle that one is cosine law. It's this one. You should have had an obtuse angle there. Maybe I'll just show you that. Okay. You do get a negative here. Immediately you should know, okay, bigger than 90, right? My angle will be bigger than 90. No questions asked. And so you have that. If you want to give yourselves a mark, 3 marks if you have that one done correctly. So 1 mark for that third angle, 2 marks for, like, normally I go 1 mark for setup, 1 mark for correct answer. And this one is only 2 marks. It's just cosine law. So I'd say 1 mark for setup and 1 mark for correct answer. I would say if you drop the negative, that's usually a -1. Okay, if you drop the negative, like if I don't see you using it, because it's a concept. That's why I keep on repeating it. It's not like you're off, your rounding is off or something, like you're not understanding that the negative means something very, very particular. It knows, cosine law knows, make sure you listen to this part, it knows that it's an obtuse angle. Sine law does not know, like sine law will never give you an obtuse angle. And that's a bit of a problem, which we will tackle a little later this week. Compass directions. I'm expecting you to be able to see this and then write the compass direction for this particular case. So I always tell my students, start with where that angle, like which one of the north, south, east, west, which one is being touched by it. In this case, 65 touches the north line, so I start with north, and then I move towards where the actual direction is, the actual path. And so it's 65 towards the east, if you want to look at it that way. This one is touching the west line, so it's west 18 degrees towards the south. Okay. This one is touching the south line. It's going 21 degrees towards the east. So I hope that makes sense. That should be pretty straightforward. Just so you know, I used to teach compass questions just like that. I just threw it in there in the word problems, and then I would just give you a crash course, and that didn't go so well. So I'm devoting some time to compass directions specifically, even though don't forget about the other ones. Don't forget about angle depression, angle elevation, those types of questions. Draw the following. So now I'm asking you to actually draw the line. So again, you start north, and then you turn that many degrees towards the west. Okay. So 1 mark for each done correctly like this. I don't know if on the video I talked about it, but you could write this the other way where you start from the east. And then you just got to make sure they add up to 90, right? So this would be 25 degrees north. Like if you said east, 25 north, you're actually talking about the same heading, okay? But I don't think that's necessarily a skill that I'm gonna like ask you for. I'm not so sure. I just need you to understand that it can be done both ways, because remember there's a 90 formed between the north and the east. So if you know this one, you technically know that one as well. So you can rewrite it in this format. So I basically cross these, like if you don't have the diagram and I just asked you to rewrite this, you would just cross them, right? Opposite order, and just make sure that these two add up to 90. These two here. And then you're fine. 1 mark for each, 1 mark for each of these. I hope that was, the challenge is gonna be when I give you a word problem and I ask you to solve, right? That's when it's gonna be harder. How was this one? I threw in a angle depression in here. They spot the shark below them. The shark is to the right of diver 1, so this is diver 1. and to the left of diver 2. So this is the scenario, and because you have angle of depression, it needs to go like this. Okay, so they're kind of looking at the shark like this, and it could be in this case it's below them, right? We have, this is our diagram, so I would say 1 mark if you have everything where it belongs, and then calculate the distance from each diver to the shark. So obviously you've got 2 angles, find a third, that's 94. So if the 94 shows up here anywhere, you get the extra mark for that. And then we use sine law to figure out, just make sure when you have questions like these where it's like which one is which, just on your diagram clearly label what side you're solving for. And then, sorry, I went ... because I had to hurry to get this one done. But the work should be there. So for from diver 1 to the shark, it's 1577. Diver 2 to the shark is 1833. And if you, obviously, if you did this at home, you're just sitting back and relaxing right now, which is good. You did the work, why not? And then the height, use any one of those slants, okay, X or Y. I think, I used X here. If you use X, just make sure you use the angle that's touching it, sine of 47, and so it's 1153 meters below the diver. So the implication here was find the height of this triangle. And you're thinking, that's not the height, that's like upside down. It's still the height of the triangle, you just have to imagine that you're turning it. And so that's how you do it. And you may have done it differently without using the formula I just did. That's fine as well. Here we go. This is the trickier one. Maybe this is worth redoing from scratch. But I did give you a little bit of a help there, like an aid. But I just need to make sure you don't make mistakes on these ones. And I probably mentioned it on the video, but I don't remember what I said on there. So we leave the parking lot at north 20 degrees west. So we're starting here. This is your north line. And so we're turning 23 degrees. So that should go there. Okay, and then you're going for 5.6. So you've got direction and you've got distance. Not always will you get both. Okay? And then we turn here. So that compass rose follows you wherever you are. Okay? So this is the turn. And we go west 23 south. So this is your west line here. So we turn 43, my bad, 43 south that way. And then we end up here. And 2.4 kilometers is this one right here. And I know I've probably said this on the video. I'm not sure. I just need you to make sure you listen to this part. Like if you're still kind of sleeping, this part you want to make sure you pay attention. A lot of students, they always want to imagine, oh, this is my start. So when they draw this line, they often draw the line and make it kind of line up perfectly with where they started. So I would caution against that strongly. I would say either go less or shoot way past it. Okay, but don't line it up because then you're going to think that there's something there that isn't there. Okay, so you've been warned about that. Okay, now this is your interpretation. I want you to always have a clean triangle. So you get rid of all the angles that don't belong to this. The easiest thing is to copy over the side lengths, right? We know that this is coming with us for sure. And I will say this, 99.9% of the cases, you should only be able to get one angle in here. Got it? Not 2 or 3, because that's going to make it way too easy. So what you need to do is resist the temptation to just bring all these angles over to here. Instead, we use parallel lines, right? So we've got this line right here is parallel to that one right there. So alternate interior are going to be your go-to. So this one comes over here. This 23 that started here is with us right over here. Okay, so that would be step number 1. Then you want to ask yourself, what else can I do? There's a 90 at this corner here. So that 43 and this angle right here, they're complementary. This one. So I'm just going to go 90 minus 43 to get that one, right? And that is 47. So this angle right here is 47. Okay, right there. Now you get to, now you have both kind of, these are not halves, okay? These are not halves. The diagram may look like it. This is 47, this is 23. So you add them up. 47 plus 23, and that would be 70, correct? So 70 is the only angle that comes with you into this scenario right here. And so what is it asking for? Is it asking for just to fill in, right? I didn't ask you to solve, but technically, most likely this question would have asked you to solve for that. So SAS, cosine law does the trick there. Okay. All right. Because, yeah, I'm going to leave it right, like, you're going to come across scenarios where you're going to be tempted to bring in angles that are not there. Okay. I'm going to kind of force it that way where you're going to think, oh yeah, this is going to be easy, but not so quick. Okay. Next, a plane leaves the airport. So this one is from scratch, right? I know you've done it already. So just pay attention to the little things that I'm adding, okay? Hopefully you've done this, because then it's so much easier. You can focus on the questions, okay? Just do it already. South 30 degrees east. So let me see, south 30 east. So I'm going to go this way, okay? So this is my south line. I'm going to turn 30 towards the east. So you go that way. This is your 30 right here. Okay, make this one, the dashed lines, just this is your start. And 230.4 kilometers. All right. Now we're going, picks up some passage. Now we're flying north 42 east. Okay, so from here, they're not always the same. I'm just going to put the north in here and the east-west line. So we're going north 42 towards the east, so we're traveling this direction. Put the 42 in there until we reach the final destination. So this is 450.1 kilometers. Stop there. So this is destination. This is your turn. All right, so that's, again, don't make the assumption that we're lining up perfectly here. Why am I saying that? Because a lot of students will be like, oh, if this is 30, then this is 60, right? All right, and so if I bring this close, then I have the 60, I have this one, and this 60 is not part of this triangle because I'm not lining up perfectly, right? This keeps going this way, but it's not touching here, so it's not part of the triangle. Ignore it, okay? The 30 goes in here, and the 42 is already in there, right? So in this case, it's just as easy as that, and that adds up to 72. So I know my clean version isn't the cleanest here, but we're going to go start, turn, destination. This is 72, this is 230.4, and this is 450.1. Okay. I think we're good. And in this case, it's asking sketch another one without the compass rose. That's this one right here. Calculate how far the airport is from the plane's final destination. So this would be the airport, and this would be the final destination. This is cosine law, and I'll just show you what you get, because the interpretation is the hardest part. There we go. 437.70 is your final answer if you did this correctly. In terms of marks, I'm going to be very easygoing today on that, because the ACs are there for you to learn. That's not really going to tell me yet whether or not you know your stuff, right? I know that, but it's going to give you a little opportunity to try it out, see where you're at this moment, okay? All right. Let's start.